right, equations of parallel and perpendicular lines. We've got some things that we need to remember from our middle school math. If we have two lines that are parallel, that means they are never going to intersect. They're never going to cross each other. They're never going to touch. And the reason for this is because they have the same slope or rate of change. So the way that the symbol that we use for parallel kind of looks like a slanted double L. So if you have parallel lines, then our slopes are going to be the same. So let's write it like this. Parallel lines have the same slope. They have the same slopes. Now, perpendicular lines, we use that symbol for perpendicular. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. So what does that mean? You may not remember what the word opposite reciprocals are. So let's do an example very quickly. If I give you the fraction 2/3, the opposite of 2/3 would be a negative 2/3, and the reciprocal just means you flip your fraction. So if you start with a positive 2/3, the opposite reciprocal is negative 2/3. If you start with a, let's say, -2, the opposite reciprocal is going to be a positive 1/2. And you might think, well, how did she get 1/2? Don't forget that any whole number can be placed over a number 1. So -2 is the same thing as saying -2/1. So when you flip this fraction, it becomes a 1/2. Positive 1/2 for the opposite reciprocal. All right, so let's do some examples. It says, what is the equation of a line in slope-intercept form that passes through the point 3, 2 and is parallel to y equals 2x plus 5? All right, so the information that we started with first here is 3, 2. And we know that we want our line to be parallel. And in order to be parallel, it's got to have the same slope. So what is the slope of the given line? Well, it's 2. So our parallel slope is just going to be 2. So if I give you guys a point and a slope, then you're probably going to need to start in point slope form. So let's go ahead and label our point x1, y1. And the formula for point slope form of a line, remember, is y minus y1 equals m times x minus x1. All right? So let's go ahead and substitute in our values. We have y minus, our y1 value is a 2, so we'll sub in our 2, and that should equal our slope. The slope that we want is 2 times x minus our x1 value, which is the number 3. So this is our equation in point slope form, and this is perfectly correct, except that our directions asked us to put our equation in slope-intercept form. Asked us to put our equation in slope-intercept form. Well, slope-intercept form is just y equals mx plus b. Y equals mx plus b. So we need to get rid of our parentheses, and we need to get our y by itself. We need to isolate y. So the first step we want to do is distribute. We want to distribute, so let's do that. 2 times x and 2 times this minus 3 over here. So I'm going to go ahead and draw my line. 2 times x gives us 2x. 2 times that minus 3 ends up giving us our minus 6. And we didn't do anything to the left side of our equation, so we'll just bring down our y minus 2. Y minus 2 equals 2x minus 6. So we're almost there, but we want to isolate our y value. We need to get y by itself. So our second step is going to be to move our constant from left to right. from the left side of our equation to the right side of our equation. So what is our constant in this problem? This minus 2 is on the wrong side. We want our y by itself. So we're going to add 2 to both sides of our equation. The opposite of minus 2 is plus 2. So we're going to add 2 to both sides. And that gives us y equals 2x, and then negative 6 plus 2 gives us our minus 4. And this is our equation right here, y equals 2x minus 4. Now, I also gave you guys a grid in this problem. So if you are paying attention to the information that you are given, you're given the point 3, 2, and it's been plotted for us, right? Our x value is 3, our y value is 2, and there is our point. Well, I know I want it to be parallel, which means it has to have the same slope, a slope of 2. So if I wanted, I could just go ahead and graph my line using the point and the slope. Now remember, our slope is 2, which is the same thing as saying 2 over 1, right? That either means I'm going up 2 and to the right 1, or I could say negative 2 over negative 1, which means I'm going down 2 and left 1. So if I start at my point and I go down 2, left 1, down 2, left 1, down 2, and left 1, I end up hitting my y-intercept, which is what I need if I want to write my equation in slope-intercept form from a graph. So if my y-intercept is negative 4, notice that was the y-intercept we got algebraically. And our slope, we already know, is positive 2. So you can either do this graphically or you can do algebraically. I need you to know how to do both methods, but they both will give you the correct answer based on the information that you are given, okay? So let's look at an equation that is perpendicular to the given information. So what is the equation of the line in slope-intercept form that passes through the point negative 1, negative 3, and is perpendicular? Now we want a line that is perpendicular to y equals negative 1/2 x plus 3. Perpendicular. Well, in order to get a perpendicular line, we need to look at the slope of the original. And the slope of the original is a negative 1 over 2. So the perpendicular slope, remember, we need to change the sign. So we go from negative to positive, and then we're going to flip our fraction. This 1 over 2 is going to become 2 over 1, or just 2. All right? So we're given a point. We'll go ahead and label that x1, y1. Oops, let me use red. x1, y1. And we're given a slope, a point and a slope. Well, that means we're going to use point-slope form when we're solving this algebraically. So y minus y1 equals m times x minus x1. And let's go ahead and sub in our values here. So we have y minus, our y1 is a negative 3. So minus a negative 3. Remember, when you're subtracting a negative, that really means plus. So let's go ahead and change that to a plus 3. And that should equal our perpendicular slope, which we know is 2, times x minus our x1 value, which is a negative 1. And minus a negative is, of course, plus. So let's go ahead and change this to a plus 1. Close parentheses. All right, so we've got our equation in point-slope form, but remember, again, we want slope-intercept form. Y equals mx plus b. So let's go ahead and get rid of our parentheses by distributing. I'll go ahead and split my equation. And 2 times x gives us 2x. 2 times 1 gives us our plus 1. And we didn't do anything to the left side of our equation, so let's go ahead and bring that information down. So it's just y plus 3. All right, so we distributed. We got rid of parentheses. Now we need to isolate our y value. We need to move the constant. That plus 3, its inverse is minus 3. So let's minus 3 from both sides of our equation. And that ends up giving us y equals 2x, and then 2 minus 3 gives us a minus 1. So this is our equation in slope-intercept form. Now again, I gave you guys a grid also. We can kind of use both methods to check our work, right? So the point -1, -3 was given. So my x value is -1, my y value is -3, so there is our point. And we know our slope is 2 over 1. 2 over 1, that just means we go up 2 and to the right 1. So let's start with our given point, and we'll go up 2, right 1, up 2, right 1, up 2, right 1. And you can go all the way across the grid if you want to. Or remember, you can go in reverse. You can go down 2 and left 1, and you'll still fall on the same line. So here is our perpendicular graph. What information do we need on this graph in order to write the equation in slope-intercept form? Well, we need our y-intercept. And our y-intercept is that -1. And if we look right here, we have our y-intercept algebraically at -1, this -1 right here. And of course, we already knew our slope because it was given to us. It was a +2. Or I guess we determined what it was. We were given the -1/2, and we determined our perpendicular slope was +2. So that's what you guys can do to write the equations of parallel and perpendicular lines. Just remember that parallel lines always have the same slope. Perpendicular lines always have opposite reciprocal slopes.